So thank you for your patience again, and welcome to our webinar. As I have seen our technical difficulties, this is not a strength, but we're working on it. What we can do really good is monitoring and control, and I hope that you will enjoy our webinar in this session from the Smart AE Industry Day. So thank you again for tuning in. We hopefully are recording this session, so if you cannot make it through the whole presentation, we'll be sending you the recording afterwards. Another thing is, you have seen maybe that the time slot has been set to 1.5 hours. Don't worry, we won't take that long. We have a rather short presentation because we know from experience that webinars are really, it's not the same as if you're in a room listening to somebody. So we don't want to stress you too much today. We have a lot of interesting information for you about our monitoring platform, VCOM Cloud, and well, you hopefully will enjoy the presentation by my colleagues. You have the possibility afterwards to send us your questions via the chat function. Hopefully this will work, and if not, you can always reach us via the website or by email. So enough of me. I let my colleagues introduce themselves. So Mauricio, the stage is yours.
Thank you, Nicholas. Thank you for this opportunity, and thanks for the invitation. My name is Mauricio Lopez. I am Head of Business Development and International Sales by Metrocontrol. I'm working here since 3 years, and I am happy to introduce you in the part of the company, our products and solutions. Let me please introduce to Fadel. He's with me today, and he will take part of the artificial intelligence part of the VCOM Cloud.
Yeah. Thanks a lot, Mauricio. Thanks a lot, Nicholas. Welcome everybody also who is joining us then for the today's session. My name is Fadel Hashisha, and I'm product manager within Metrocontrol since 4 years now. And I'm working together with our product team on the continuous development of our VCOM monitoring platform. So I am happy today to talk about our latest implemented data management technologies we implemented in our software, and I will be glad to give you an insight on this matter today. Before we will deeply dive into this technical aspect of our today's session, I will give in the first step the word to my colleague Mauricio for an introduction of our company, for an overview about our VCOM Cloud solutions. So Mauricio, the word is again yours.
Yeah. Thanks, Fadel. Thanks. So I think we are already sharing the desktop, right? So we're gonna start with the presentation of today's topic. Let me please say some words about the company, about what is where we're coming, where we're going. And Metrocontrol is with more than 40 years experience in the sector. We are one of the more than 40 years experience in the sector are giving us the opportunity, or giving us the position as a leading of PV monitoring power control solution for any kind or any size of PV plants. So from huge utility segment to single PV installations, our solutions are able to. We are represented in all 5 continents. We are with more than 180 people. We have more than 12 locations now, and some other numbers are that we have more than 50,000 PV installations as more than 50,000 installations and more than 18 gigawatt under monitoring in our portfolio. Correct. Which is part of our products, our solutions, what is our portfolio. We have not only the VCOM Cloud, which Fadel will talk deeply after my words. We have also the hardware and the heart of the data collection, the most important part in the PV field, to have a reliable hardware to collect the data, to warranty the data that we will collect. And also we have two other services that are independent technical advisory and the solar power forecasting. Today we will talk, or Fadel will after this talk a little bit deeper in the VCOM Cloud. Okay, the VCOM Cloud is based on apps and on a VCOM CMMS add-on, and for sure the remote monitoring platform. And why the remote monitoring platform of media control, which is the point of this presentation today, is because it is highly flexible. Okay, it is highly easy to work with. It allows you as portfolio management as also system in each system. And the key of today is the interface and how flexible we are with the interface, and how easy we can exchange data and what are we doing with this data. And correct, and Fadel will now explains us exactly how we are working with this data and how are the analysis of this data and how we are improving the working with this data. So Fadel, the word is yours. Thanks.
So thanks a lot also from my side, Mauricio, for the introduction. Welcome everybody also from my side, for everybody who has joined us the last minutes. I will be glad today to talk a little bit about our new approaches dealing with the data we are importing in VCOM and how to improve our software for the monitoring of PV systems. Before we jump, we dive deeply into the topic of machine learning, artificial intelligence, I wanted to mention the sentence of Teresa Torres talking about continuous habits discovery in the software development of the products in general, where she said once, it's not just about continuously improving our products, it's also about continuously improving our practices. And that was from our perspective, from the product team working on the development of our software. We've been the last couple of years working on releasing new features, improving already implemented features from last years. But we mentioned also, as mentioned, we observed also, as mentioned by my colleague Mauricio, that our open import interface allows us nowadays to import data, to import really a lot of data from all kinds of systems of PV plants from all over the world. So we've been in a constellation that we have a lot of data being important into our product. And obviously for us, it was sometimes the question how we can deal better with this data, how we can get the best of this data, how we can improve our practices with this data in order to improve our products. So in general, why we are doing this? Because in the end, from our side, but also for our customers, we want to improve the user experience and provide our customers with the right tools in order to optimize the time efficiency in the daily business of the O&M processes. Because in the end of the journey, our customers, we, but also all market actors in the PV sector are aiming definitely for more green energy generation in the future. So how we decided to go for tackle this big topic, how we optimize, let's say, our practice in order to achieve our goals together with our customers. We decided to go for data-driven and component-based digital twin. That means we want to get also the best of the data we are importing into our monitoring platform in order to have an estimation about how much should be the system being producing in terms of power, how much should be the components, the inverters of the system being producing in terms also of power. So we are doing this process of the machine learning implementation both on system and inverter level, learning the normal behavior of the system and the inverters, which will allow us to detect in an intelligent way the deviations between the target value calculation and the measurement data observed on site. Because in the end, what we want also to achieve for us, for our customers, we've noticed the last couple of years again that the portfolios of PV systems are getting bigger and bigger, that PV systems, the PV plants are getting complexer, and it was obvious for us, again, as a provider of a monitoring software tool, that we have to provide our users with the right tools in order to detect the right problems. It means, in other words, we should be able to provide information in easy steps to detect which asset within my portfolio is in critical state. And once the systems which are critical are detected, we should also provide the information, what are the components, the faulty components behind these critical assets. This is what we want to achieve with the new practices we implemented based on the latest data management technologies. So now, if we will have a deeper look now on how we tackled this issue, how we decided to implement our new practice, we decided to go in two steps, in a two-steps model based, first of all, on a physical model. It's really a theoretical model which allows us, based on the technical data of the system, on the temperature, on the irradiance, to have the first iteration about this target value calculation, again, both on system and inverter levels. And now here comes the newest implementation, the newest practice we implemented the last month. This physical model, it could be also really robust in a perfect world, but the reality says that the systems, that the inverters could be performing based on the local conditions of the local location of the systems. And this is why we decided also to consider both the physical model and the historical data measurement as input parameters for our machine learning algorithm in order to learn what is the normal behavior of the system, what is the normal behavior of the inverters. That means this approach will allow us to exclude automatically all systematic errors which are directly related to the system itself. Typical case is shadowing effect, in a way that the optimized target calculation from the physical model with our machine learning simulation would be able to allow us to detect only purely technical issues on the system or on the inverters. So if we have a day in this use case for our presentation today, this screenshot above show us the target value calculation about the whole system. This is the range, the light blue range on the screenshot. And this target value calculation is also compared directly with the measured data of the system. In this case, we are observing here on the system level a deviation between target value calculation and the measurement data. This deviation is displayed, interpreted in this case as losses. So we are able here in this case to bring the information that the system is not performing as expected. So why we went we decided also to went for an inverter-based simulation also. We are running also again the simulation on inverter levels. So after every data input, we are also able to calculate the target value for each inverter in a way that we also can have the information that the inverter here, 2 out of 5 inverters of this system are in completely outage when here in the system. And this proceed will allow us also to have the information after every data input we are importing into our VCOM monitoring platform. So I mentioned at the beginning of my presentation also that we are aiming also to give our users with the right tools to also detect the critical assets within a portfolio, within a big portfolio of PV plants. And this approach based on the inverter simulation, this live evaluation of each inverter, this live comparison between target value and measured value of each inverter, allowed us also to present a new feature which is released the last couple of months in our performance overview for the whole portfolio management, which provides with an easy and simple overview of how the inverters of each system are performing. In this way, it is possible to identify easily critical system for an effective on-end process. And so with this column concretely, the inverters are evaluated based on this simulation, and depending on the deviation between the target and measurement values of each inverter, 3 different states are displayed as stacked horizontal columns and then reflect the number of the affected inverters in the respective state after each data input. So we have in this way, with this overview, the whole representation about the performance of every component of every system within our monitoring platform. So I mentioned also at the beginning, as I started with the presentation of our new practices, which is implemented, that we are excluding based on the machine learning simulation all the systematic errors automatically. Typical cases are the soiling losses, degradation losses, snow losses, shadowing losses. All these losses are due to the long bad performance of the systems. The machine learning simulation allows us, on the one hand, to exclude these errors, and what we are aiming to do beside this losses display about the technical behavior of the system in the inverters, also to make the classification of all the systematic errors which we learned with the machine learning simulation. So what we want to achieve on the one hand, to detect purely technical issues, as we saw in the last use cases, but also to run the long-term evaluation of each system. What we are able today, also based on this waterfall chart, that we want to classify these losses, what is already implemented in this case, in case of power containment. If the system is being under containment from the grid operator, from the aggregator, we are able with this practice, with this proceed, also to estimate the losses based on this containment. And as it is not a normal behavior of the system, as it is not a normal behavior of inverters, these time steps are not considered into our training algorithms. So what we want to achieve also in the near future to go further on with the classification of these errors besides the technical issues. As an outlook from my side, it is of course nice, it is also good to have the right charts, to have the right information about the performance of the system, about the inverters, about the portfolio, to see where I am losing at most energy within my system based on the use cases we saw together. But what we want also to achieve in the near future based on the new practice we implemented, that we want to use this information also to detect and intelligent alarms that should be used as action items for our own end managers on the one side. That means we should also bring the information as a concrete information for the own end manager in order to undertake the right decisions to solve the issues. But also on the other hand, what we are working on already with this implementation, that we want to go further on with the classification of these systematic errors that we have from a technical asset management perspective, also an overview about the long performance of the system over the long period of time. Of course, the machine learning topic, the newest data technology, which we have already implemented into our software, this is something completely new for us. This is something completely new also for our customers, but also in general for the software development. So we are now in the situation, in the point that currently the machine learning simulation is learning the data we are importing into our platform, but we are also in the phase that we are learning what is the machine learning simulation also doing in this case. And this is only for us the beginning, the base to go further on with these newest technologies to be able to detect issues easier in a simple way for the portfolio management of PV systems. And this way, once the issues are solved, we will achieve the goal I mentioned at the beginning, that we will have more green energy generation of the portfolios from PV plants. So that was the insight from my side. Thank you very much from my side also for the presentation. It's time to you to have questions. We will be glad to answer these questions together with my colleague Oesio. Thank you very much again.
Okay. Are there any questions? Okay. Here's one question. Do you offer your services in all European countries?
Sure. Let me respond to this question. Yes, sure. We are. We have not, as already mentioned, we have offices in France and in Italy. So for sure, we are offering our systems in all European countries. So sure.
Okay, thank you. There are no further questions that I can see right now. So let's wrap it up. It's been a fun lunch break. Thank you all for participating. We'll be in touch with you, and hope you don't miss our second webinar tomorrow at 16 hours about our hardware solution, BlueLock. And hope you will enjoy the rest of the sessions at the Smart AE Industry Days. We surely hope to see you all in person without any technical issues on our booth at Intersolar this year in October in Munich. Hope to see you all there. Hope you enjoyed it. If you have any questions, reach out to us. Have a great day. Goodbye, and thank you to my colleagues for doing this.
Thanks to all of you again, also from my side. Thank you.
Thank you. Bye.